Hi, I'm Mohan Prakash.
I'm Alex Barber.
I'm Marcelino Torices.
I'm Andrew Ruiz.
I'm Pascal Klepser.
This is our presentation for our Advanced PLC semester project. We use Factory I/O to simulate a production environment using webcams to monitor workers for PPE and hand gestures, and an OV20i camera for part inspection. The goal of this project was to produce a system that improved worker safety and efficiency.
This is a demonstration of our full system. First, you need to make sure all PPE objects are okay, which is demonstrated by me wearing a vest and a helmet and goggles. Then, to start the system, give it a thumbs up. Now the system is running. Now we can enable PV3, which loads a part. The part will move. Then it reaches inspection. I will then press inspect part. It is a good part, so it'll pass. And then we will be switching the part. And then we load another part. The part moves down the conveyor. Then inspecting the part is picked up by the robot and put on the bad conveyor for disposal. I'll now demonstrate the switching part process. For switching a part, which one we want to work with, I will want it circle. So we'll do switch 4, which activates the circle recipe, and switch 1, which locks it in for what the camera is going towards, and now recipe match. So I will undo those. So now we're searching for circles. So then if we put a good circle and we run the program, and then inspect, it will pass. And if I hold up a stop, see it stopped right before, want it to move again, thumbs up, runs it.
So this is the ladder logic that we have come up to control our program. So it has the main routine and 4 subroutines, each performing their specific function. So this is the main routine. The main routine has a safety layer and a hand gesture control layer to it. Once the safety layer is true, only then the power is supplied to the conveyor, to our simulation. Based on the part that needs to be inspected, the switch subroutine is called on, where it confirms the part shape and the inspection that needs to be performed. Next, we push the PBV3 push button to load the part onto the conveyor. Once the part arrives to the inspection stage on the conveyor, push button PB1 is pressed to call the inspection. This in turn will call upon the subroutine check part, where the camera performs the inspection and gives up either a pass or fail result. The this pass or fail result are then recorded back to the main routine and recorded there. If it is a pass, if we get a pass result, then this calls upon the pass routine, where the part travels, where the part is accepted and it travels on the conveyor for the next assembly. But if we get a fail result, then the fail routine is called from the main routine. And the fail routine actuates the robot in the simulation to pick the part and place it in the wrong part conveyor, which later dumps the part into a rejection pile.
We trained 3 different part evaluation models, one for each of the shapes we were detecting: circles, squares, and triangles. The evaluation models are detecting the print quality or any scratches or burrs that would be harmful later down in the process. The camera interfaces with the PLC through an Ethernet cord. The PLC sends image capture requests to the camera, and the camera sends back pass or fail, along with multiple different status bits that we use in the program. You can see here a result of a good circle inspection, and then we'll return to live and capture this bad circle. And you can see that failed with 100% confidence value. Now we'll swap to the square detection recipe. And once this is live, you can go back to the HMI, and you can see there's a good square in there. We'll capture that. You can see another 100% pass detection, and then return to live. And now if we put in a bad square, take a picture of that. You can see it easily captures and understands that this is a bad square with 100% fail.
Our inputs and outputs are set up via RSLogix 5000 that can be interacted with by the programmable controller system and worker monitoring systems that interact with Boolean inputs and outputs that control the sensors and the actuators within Factory I/O. And these systems can control the conveyors and the robot.
Okay, for the hand recognition portion of our project, we decided to use MediaPipe, which is an open source model developed by Google. MediaPipe basically automatically detects a hand, and once a hand is detected, it maps a coordinate point to each joint in the hand. Looking at the joint, so basically it maps each coordinate point to the hand, and using the mapped coordinate points, we were able to train the model on 3 different gestures. So one of them is open hand, then thumbs up, and fist. So open hand stops the program, which is the conveyor stop. Thumbs up starts the program, which is the conveyor run, so it activates this bit and starts the memory bit. And then slow activates our slow warning light, which would be conveyor slow.
The PPE detection system utilizes a YOLO V11 model trained to search for a person, a helmet, a vest, and goggles. It outputs a Boolean signal to the to RSLogix to integrate with the PLC and the simulation. You have your helmet, goggles, vest, and person.